Hello dear students, welcome back to EduHunt online teaching platform. At the section today, we are going to discuss about progression, which is a part of 9th class mathematics. So let's go to progressions. First, who is the father of progressions? So Carl Friedrich Gauss. He is a German mathematician. So who is the father of progressions? Carl Friedrich Gauss. So first one, very important point is sequence. In that progression, first one we need to learn sequence. So in that case, a sequence is a list of numbers arranged in a specific order according to a rule or pattern. So sequence nothing but a list of numbers arranged in a specific order. So specific order according to the rule or pattern. So that is called sequence. The numbers in a sequence are called its terms. We refer the first term of sequence as T1, second term as T2, third term as T3, and so on. Am I clear? So firstly, so sequence. A sequence is a list of numbers arranged in a specific order according to rule or pattern. So for example, what I am given example 2, 4, 6, 8 and so on. So this is also sequence because a sequence list of numbers. This is a list of number arranged in a specific order according to the rule. Here what is the rule? So our pattern. Rule means each one increased 2. So 2 is a common difference. So 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8. Am I clear? So this is called sequence. Am I clear? So next one, sequence are two type of sequence are there. First one, finite sequence. A sequence which consists of a finite numbers of terms is called finite sequence. So what is a finite sequence? A sequence which consists of finite numbers. So for example, 2, 4, 6, 8, 10 is a finite sequence because it has a limited number of terms and ended with 10. Already that sequence ended with 10. So for example, what is another example? For example, if you are taken 2, so what I am given here, example, finite numbers, nothing but 2, 4, 6, 8, the number of terms and ended with 10. So already it is ended with 10. So here how many terms given? 5 terms, 2, 4, 6, 8, 10. So clearly we need to notice that. So let me given the second example. So for example, if you are taken 1, 4, 9, 16, 25. It is also finite sequence because ended with 25, 5 times given. Okay na? 1, 4, 6 and 1, 4, 9, 16, 25. These are perfect squares. 1 square, 2 square, 3 square, 4 square and 5 square. Am I clear? So what I am given the finite sequence definition, a sequence which consists of a finite numbers of terms, finite number of terms is called finite sequence. So infinite sequence, second one is infinite sequence. A sequence which consists of a infinite number of terms is called infinite sequence. For example, 10, 20, 30, 10, these are 40, 10, 20, 30, 40 and so on. And so on means this is called infinite sequence. So these are multiples of 10. This is an infinite sequence which a constant difference of 10. So 10 is a constant difference, but here constant difference also very important. For example, what is another example? Suppose if it is given 1, 3, 5, 7 and so on. This is infinite sequence with a constant difference is 2. So it is called odd series, odd number series, infinite odd number series. Am I clear? So let's go to series. So what is series? The sum of the terms of sequence is called series. The sum of the terms of sequence is called series of a corresponding sequence. For example, 1 plus 2 plus 3 and so on n. This is a finite series of the first n natural numbers. So what is the first n natural numbers? 1 plus 2 plus 3 plus and so on n. So what is the sum of the first n natural numbers? Sn equals to, or capital sigma n equals to. So this is a finite series, nothing but sum of the first n natural numbers equal to n into n plus 1 by 2. This is a formula. Am I clear? So if it is given a sum of the first n square natural numbers, n into n plus 1, 2n plus 1 by 6. So if it is given cube natural numbers, first n cube natural numbers, sigma n cube equal to n into n square into n plus 1 whole square by 4. These are very important formulas. So what is series? Sum of the terms of sequence is called series of the corresponding sequence. For example, 1 plus 2 plus 3 and so on. So sum of the n finite series. with first n natural numbers. So sum of the first n terms of series is denoted by Sn. So denoted by Sn. So what is Sn formula? T1 plus T2 plus T3 plus and so on Tn, where Sn stands for T1, S1 stands for T1, nothing but first term, S2 stands for first two terms, sum of the first two terms, S3 stands for sum of the first three terms, S4 stands for sum of the first four terms, and so on. Sn stands for T1 plus T2 plus T3 and so on Tn. So it can be written S2 minus S1. Suppose if you take an S2 minus S1, so S2 minus S1, what is S2 formula? Already obtained T1 plus T2. T1 plus T2 minus S1. What is the S1 formula? T1, first term. So T1 cancel, T2. That is S2 minus S1. So, okay. So next one, S3 minus S2. S3 minus S2. S3 formula, first sum of the first three terms. So T1 plus T2 plus T3 minus S2, nothing but sum of the first two terms, T1 plus T2. So before a minus given, so it can be written as T1 plus T2 plus T3 minus T1 minus T2. You can multiply it by negative sinus, both are negatives. T1, positive T1, negative T1, positive T2, negative T2 cancel. So what you are getting? T3. And similarly, Sn. So what you are getting? So this is a Sn value, this is Sn minus 1 value. Am I clear? This is very important formula. Sn nothing but, so Sn value nothing but S3. So that previous term is S2, nothing but, what is the right side of term? Sn minus 1, nothing but 3 minus 1, 2 equal to Tn. Tn means T3. Tn means Sn, n value 3, T3. So what is the Tn formula? Tn equal to Sn minus Sn minus 1. This is very important formula. Am I clear? So let's go to worksheet number 1. Have a look at question number 1. A sequence which consists of a countable number of terms is called option A, finite sequence, option B, infinite sequence, option C, finite series, option D, none of these. Already told you a sequence which consists of a countable number, nothing but finite numbers. So clearly we need to understand what is the definition of finite sequence. A sequence which consists of a finite number of terms, nothing but countable. So countable terms is called infinite sequence. So the first definition as given in that question, a sequence which consists of a finite number, nothing but countable number of terms is called finite sequence. Option A is right answer. So let's go to question number 2. Nth term of the sequence Tn equal to n plus 3 by n minus 1, then T5 is option A 13, option B 13 by 2, option C 13 by 4, option D none of these. So nth term already given, Tn equals to, so 2n plus 3 by n minus 1. But question what I am asking? Fifth term, nothing but Tn. So n value 5 given directly, n replaced by 5. It can be written 2 into 5 plus 3 by 5 minus 1. So 2 5s are 10 plus 3 by 5 minus 1. So it can be written 10 minus 1. So these are 10 minus 1, 9 plus 3 by 5. So 5 is the LCM, okay. So 9 5s are 45 plus 3. Then answer is 48 by 5 is the required answer. Option D is none of these. Am I clear? So let's go to question number 3. Nth term of the sequence Tn equal to 2n plus 5, then the S5 is option A 27, option B 40, option C 55, option D none of these. So nth term of the sequence what I am given, Tn equals to 2n plus 5, but question what I am asking? Sn, S5. S5 means sum of the first 5 terms, nothing but it is what is the formula? T1 plus T2 plus T3 plus T4 plus T5. So sum of the first 5 terms in a sequence, that is called S5. So first one we need to find a T1 value, n value 1 taken, nothing but 2 into 1 plus 5. 2 1s are 2 plus 5 7. T2 value 2 into 2 plus 5. So 2 2s are 4 plus 5 9. Again T3 nothing but 2 into 3 plus 5. So n value 2 into 3 plus 5. So 2 3s are 6 plus 5 11. Next T4. So 2 into 4 plus 5 8 plus 5. 2 4s are 8 plus 5 13. But question what I am asking, S5 sum of the first 5 T5 also. T5 nothing but so 2 into 5 plus 5. 2 5s are 10 plus 5 15. So those values T1 to T5 values, T1 T2 T3 T4 T5 values already got 7 9 11 13 15 respectively. So those values directly substitute in that equation we will get. So T1 value 7 plus and again T2 value 9 plus T3 value 11 plus T4 value 13 plus T5 value 15. So what is the total? 7 plus 9 16, 16 plus 11 27 plus these 28, total 55. So which option is right answer? Option C is right answer. Am I clear? So let's go to question number 4. Sum of the terms of sequence is called series. Option A, finite sequence given. Option B, infinite sequence. Option C, series. Option D, none of these. So sum of the terms of sequence is called series. Option C is right answer. Already explained that fundamental concept of progression. Am I clear? Let's go to question number 5. Nth term of the sequence 1, 1, 2, 3, 5, 8, 13 where T0, T1 equals to 1. Option A, Tn equal to T n minus 1 plus T n minus 2 and where n greater than or equals to 2. So where n greater than or equals to means what? 2 or more. And should be starting with 2 or 3 or 4 and so on. So option B, Tn equal to Tn minus 1 minus Tn minus 1 n greater than or equals to 2. Option C, Tn equals to Tn minus 1 into Tn minus 2 greater than or n greater than or equal to. Option D, none of these. So nth term of the sequence already mentioned 1, 1, 2, 3, 5, 8, 13. But question what I am asking? So nth term. So nth terms. So all terms. So already given. So but first thing T0, T1 terms already equals to 8. Sorry 8. This is 1. T0, T1 value already given 1. Okay. So first two terms already coincide 1, 1. So it is clear T0, T1. T0 value 1 as well as T1 also 1. But how we will get T2? So through options, option verification, what I am taken first, option A, what I am taken Tn equals to Tn minus 1 plus Tn minus 2, where n equals to greater than or equals to 2. So nothing but T2 taken, n equals to 2 taken first. So 2 is substituted in that equation, we will get Tn minus 1, nothing but 2 minus 1 plus Tn minus 2, nothing but 2 minus 2. It can be written T2 minus 1, 1 plus 2 minus 2, 0. T1, no, T0 already 1 given, 1 plus 1 equal to 2. So third term should be 2. So first two terms already given 0, 1, 1. So third term 2 already satisfied. And then we have to calculate a T3 term. So T3 nothing but n replaced by 3. So T3 minus 1 in the option 1 verification method. Plus T3 minus 2. So what is T3 minus 1? T2 plus this is T1. T2 value already got 2. So 2 plus T1 value 1 equal to 3. So fourth term is 3. It is satisfied. And also we'll get T4. T4 we can calculate T4. So according to verification, so what is Tn formula? Tn minus 1 plus Tn minus 2. So nothing but T4 minus 1 plus T4 minus 2. It can be written T3 4 minus 1 3 plus T4 minus 2. So T3 T2 already got 2 T3 value 3, T2 value 1, T2 value 2. So clearly T3 value 3 plus T2 value 2. What is the total? 5. So next term also 5, but in that sequence already given 5. So it is satisfied and so on. So option A is the required answer. Option A is satisfied. Option A is right answer according to option verification. Am I clear? Let's go to question number 6. Sum of the n terms of the sequence Sn equal to 5n plus 3, but question what I am asking T4. So T4 value asking. Option A 23, option B 18, option C 5, option D none of these. So clearly we need to notice that. So in that case already given the formula. So Tn equals to Sn minus Sn minus 1. What is the formula? Tn equals to Sn minus Sn minus 1. But question what I am asking? So already told you that formula in that fundamental concept of progressions. So question what I am asking T4. T4 can be written. So nothing but here n value 4 given. So Sn nothing but S4 minus S4 minus 1 nothing but 3. N minus 1 nothing but 3. So clearly we need to notice that. So already given Sn value how much given here? 5n plus 3 given. First one we need to find S4. Nothing but n equals to 4. So it can be written 5 into 4 plus 3. 20 plus 3, 23. 5, 4 is 20 plus 3, 23. As well as S3. N value 3 taken. 5 into 3 plus 3. 5 3 is 15 plus 3, 18. So already got S4 value 23 equals to S4 value 23, S3 value 18. 23 minus 18, 5 is the required answer. Option C is the right answer. Am I clear? So remaining models I will discuss you later. So thank you for watching my videos. Have a nice day. Jai Hind.